Good morning. Okay, hope everyone's doing well. We're going to go through, I think, probably just this question today, BC2. It has a lot of parts. So we'll probably just stick with this one. I don't know. We'll see how it goes. Okay. Daily reminder, log on to the AP demo. Make sure you've gotten your confirmation for your tests. Be practicing FRQs, studying formulas, watching the YouTube playlist from AP, and what else? Taking PFAs, all that good stuff. Passed my first one in a while. So proud. All right. Let's do it. So, part A. So we have a piecewise function that is f. We have this dw dt, this differential, and we have an initial value for w, that w of 5 is 1. Okay. So part A, find the value of k such that f is continuous at t equals 5. All right, so going back to talking about continuity. All right, it's been a while since we've proved something is continuous or not. Okay, so a reminder of what it means to be continuous. So that means the limit as t approaches 5 from the left would be the same thing that we get as t approaches 5 from the right, which would be the same thing that we get if we actually plug in f of 5. Okay, so we're going to go through and we're going to check all three of these things to see how can we make sure that they equal the same thing, because that's what it means to be continuous. All right, so that's our goal. Prove the left-hand limit equals the right-hand limit equals the actual value of the function. So let's first start with f of 5. Okay, so f of 5, here's the function for f. It's a piecewise function, so I should be using this portion of it because 5 is less than or equal to 5. And it tells me actually if for this part use w prime. Okay, so this would be the same thing as w prime of 5. Well, what is w prime? Well, that's just the derivative. So here's my equation for the derivative. So actually this is just dw dt evaluated at t equals 5. All right, so I'm going to plug in t equals 5 to these things. So negative 1/4, 13 minus w. So I'm not plugging in 5 to, for w. But what I am doing is plugging in 5 4w, not 4w, but into the function. I'm plugging 5 into the function w plus w of 5 squared. Okay, so this is not w times 5. This is w of 5. All right? Because we already know what w of 5 is. It's 1. Morning, RJ. So negative 1/4, 13 minus 1 plus 1 squared. Normally I would say if this were just the only final answer we were doing, I would say don't worry about simplifying this, but we're trying to prove that things are equal, so I'm probably going to have to know specific values for each. I'm going to, like I said, for continuity, we need to prove that 3 separate expressions are all equal to each other, so I probably should simplify it to be able to tell that all of them are actually equal. Right, negative 4th times 12, so negative 3 plus 1, negative 2. We have you on the big screen in the family room while we eat breakfast. Oh, jeepers. Okay. We're really making moves now. That's probably one of the worst decisions you could probably make, but okay. Hey, Reese. I think RJ and Hayden, you guys have this on just like in your family rooms too, right? Your whole family's watching. Really, I think calculus is a family event. I've been saying that for years. Everybody always hears me say that. So I'm glad that it's finally being taken to heart. Okay, so here's the value for f of 5. Now I want the left-hand limit. So the limit as t approaches 5 from the left of f. Well, if we're approaching from the left, right, to the left side of 5, so stuff that's less than 5, well, we already know from our piecewise function, if we're coming from the left, then we're using w prime. Well, we just calculated what w prime is. It's negative 2. So the left-hand limit, we can trivially deduce that it's negative 2. Right? I'm trying to use big words to impress Reese's family. Right. And now let's do the limit from the right. Okay, so as we approach 5 from the right, so when we plug in things that are larger than 5, so we know that we should be using this second piece, right, because this is for t greater than 5, negative 2 over t to the power of 3 minus 4k. So negative 2 over, I already forgot what it was, t 3 minus 4k. All right, and my goal here is that I want this to equal negative 2, right? That's my hope. Because that's what we've got when we took the actual value of f. That's what we got whenever we took the left-hand limit. So now, hopefully, in order to prove that it's continuous, we want to make sure that the right-hand limit is also going to equal negative 2. And so actually, I shouldn't have t here because, again, we've decided we're approaching 5 from the right. So instead of t, I'm going to have 5. Okay, so I'm going to look at this separately. Okay, so I need to solve this because, again, the question is what value of k is going to make this true? Right, so basically I'm trying to solve for k. I'm going to rearrange here. So I'm going to divide both sides by -2, and I'm also going to multiply both sides by this denominator, 5 to the 3 minus 4k. So -2 over -2 would be 1. Now we can consider if whatever is on this right side, 5 to the power of something, is going to equal 1. So I think to myself, what exponent is going to create 1 on the left side? So 5 to the 0 power, well, anything to the 0 power we know is just going to equal 1. So now this question becomes, how can I make this exponent be 0 so that it equals 1? So now I'm just going to take 3 minus 4k equals 0. If I solve that, I'd get k equals 3/4. Okay, so there's my answer for what k should be in order to prove that, in order for this to be continuous, because if k is 3/4, then that means this limit is going to equal -2, right? That was my goal, because that's what the left-hand limit is, and that's what the actual value of the function is. So if all three of those things equal the same value, in this case -2, then that would show that it is continuous. Right. So I don't need to explain. Yeah, find the value of k, show the work, it leads to your answer. Great, I did that. I did a lot of work. I have my answer here. K equals 3/4. All right, part B. So same setup of the function, but now we want to find the second derivative at t equals 5. Right, second derivative of w. We already have an equation for the first derivative, so let's just take the derivative again. Okay, so first let me just figure out what is the derivative in general. Right, before I plug in t equals 5. So let me just take the derivative. -1/4 times 13 minus w. Okay, so this would give me 1/4 dw dt. Okay, because if you need to, think about what's happening here. If you want to think about it distributed, so that would be -13/4 plus 1/4 w. So when I take the derivative of this, the -13/4 is gone. That equals 0. The derivative of 1/4 w is 1/4, but this is implicit differentiation, so we need to, basically do the chain rule. So the derivative of w is dw dt. Plus w squared, so that derivative would be 2w, but again, chain rule, so dw dt. This is just the general formula for it, so now let's actually figure out at t equals 5. So we'll evaluate it at t equals 5. 1/4. Now, what is dw dt at t equals 5? Okay, we already figured that out. Right, from part A, we already know what the derivative is at t equals 5. It's -2. So I'm going to use that here. So 1/4 times -2. Okay, plus 2 w. If I plug in 5 to w, we already know that from our initial values that the problem gives us. We know that equals 1. So 1. And then again, dw dt evaluated at 5. I know from part A that that's negative 2. If we don't need to use this for anything, then I would say just leave this here as my answer without simplifying. If you do simplify, so this would be negative 1/2 minus 4. RJ, you still here, buddy? Can you tell me what negative 1/2 minus 4 is? I'm going to kick that over to you if possible. Oh, no. Come on, we believe you. Reese's family is counting on you. Four point 4.5? What? That's not even right in decimals. Oh, negative 4.5. Oh, okay. Don't make me come over there. Dude, Hayden will come for you, all right? He knows all the strategies from Mrs. Lee on how to sneak up on somebody. Negative 9/2. Legendary. Wonderful. Again, I don't know if we need this. I would say on the AP test, if you're deciding whether you need to simplify or not, I would say first, initially stop here. However, if you then need, if it turns out that you need to do something with this value, so you should simplify it, then go back and simplify it. But otherwise, I would just, leave it here. But like if part C suddenly asks to use this value from part B, well then I'll go ahead and simplify it. But I don't know. Okay, do I need to explain anything? Nope, it just says find the second derivative at t equals 5, so I'm good. I don't have to explain what it means in context or any nonsense like that. All right, part C. Use Euler's method with 2 steps of equal size starting at t equals 5 to approximate. So Euler's method, 2 steps, start at t equals 5, approximate w of 4. All right. I can do that, I think. So the general formula for Euler's method that's kind of bad. Let me fix that. X n minus 1 y n minus 1 times h. Okay, this should just be something that you know. Okay, for using to approximate Euler's, or approximating using Euler's method. Again, typically always for Euler's method, we'll make a table. I think that's the best way to do it. So we have n, t, and w. So we have t and w here is basically like my x and y. I don't know that it particularly matters what you label the table. As long as you're still ending up at your correct values, whatever makes the most sense to you. I know in the formula we use like this x and y, so if you want to think about it as x and y, that's fine. It's not a big deal, I don't think. All right. We know this is 2 steps, so n will start at 0 and go up to 2. Right? Our initial value we're starting at t equals 5, so I'll start at 5. And we already know from the problem, if t is 5, then w is 1. Okay, so here's all of my kind of my starting point of information. I guess I should also determine what h is. So for t is starting at 5, and we are going to reach 4. Okay, so to go from 5 to 4 in 2 equal steps, then we should be going by halves. Right, so t, when n is 0, t is 5. When n is 1, so t is decreasing, goes down to 4.5, and then down to 4. Right, so we can determine h is 1/2. Right, because go from 5 to 4 in 2 equal steps. Okay, so let's first figure out our first y value here, or value, you know, of the function w, whatever. So that would equal y0 plus dy. Actually, I'm just going to use the actual values. So I'm not going to waste time plugging in just the 1 and the 0. Okay, so y0 in this case, so my first y value is 1. Right. Plus dy dx in our case is dw dt. Right, again, because t is basically like we're treating as x, w we're treating as y. So whenever I have dy dx in this original equation, I'm referencing dw dt. Okay, so dw dt, if I plug in 5 and 1, so that's this stuff, so negative 1/4, 13 minus w of 5 is 1, so 13 minus 1, plus w of 5 is 1, so 1 squared. Right, and then times h, so that's times 1/2. We already know what all this stuff is. We already figured that out of dw dt, whenever t is 5, that goes all the way back to part A. Right? We already know that that's negative 2. It's negative 2 times 1/2. So that would be 1 minus 1, which is 0. So my first y value, when n equals 1, I have 0. Okay, so now let's find the second y value. So we use our previous one, which is 0, so 0 plus dw dt, but now I'm plugging in these values. So negative 1/4, 13 minus w of 4.5 we know is 0, so 0 plus 0 squared times h, so times 1/2. Luckily there's a lot of zeros in here, so 0 plus we don't really need. Negative 1/4 times 13, so negative 13/4, plus 0 squared, so that's just negative 13/4 times 1/2. So that would equal negative 13/8. right? And that's all I needed to find. So what does this actually mean? So this represents the approximation for what W is whenever T is 4. So W of 4 is approximately negative 13/8. Thanks to good old Euler and his wonderful formula. What a guy. Part D. So you can see I've got some series stuff going on now. Seems fun. Let dn equal f of n. For which values of k will the series from 6 to infinity of dn converge? Give a reason for your answer. Okay, interesting. So I have this infinite series starting at 6, going to infinity of dn. But I know that dn is the same thing as f of n. I'm going to write this out. You probably don't need to all the way, but... And f of n is just based off of f of t, right? Except it just, instead of t, we're writing n. Now, which part of f should I use? Because f is a piecewise function. Should I use this first piece or the second piece? Well, take a look. We're starting at plugging in 6. So that would fit with the t greater than 5. Okay, so we'll be using this second part of the piecewise function. So really, this is the series from 6 to infinity of negative 2 over t to the 3 minus 4k. Or sorry, not t, because we changed it from t to n. Okay, so I'm trying to think about all my different ways that I can prove that a series is converging or diverging. So the ones that we specifically have to know for this year's AP test are geometric, alternating series, harmonic or P series, and using the ratio test. Okay. Hold on, someone just knocked on my door. Okay, that was weird. Okay. What stupid thing was I saying? Oh, the different tests. Yeah, geometric, harmonic / P series, alternating series, or ratio test. Okay, this doesn't look like an alternating series because it's not in that form of like having a -1 to a power of something. Doesn't particularly look geometric at the moment. Maybe I could change it around to make it look like it. Ratio test, could maybe use ratio test, but ratio test is really good if we're talking about factorials or if n is in the exponent, which it's not in this case. So I'm thinking about a p-series. Right? I'm thinking I can sort of change this to look like a p-series. Now, Hayden, you'll remember p-series is the one that you got those rules backwards on. All right, so first I'm going to take this -2 that's in the numerator and just move it out in front. So this is 1 over n to the 3 minus 4k. Okay, so now this definitely does look much more like a p-series. It's just now, instead of just having, some number, we have 3 minus 4k. But that makes sense because the question asks us for which values of k. So I need to think to myself, when do p-series converge? Right, so this is the one that we all screw up on. All right, I still haven't passed it though. Well, that's because you never took it again. You literally would have gotten like 9 out of 10 if you had just swapped. You just got the rule backwards on all the p-series questions. So all you had to do was just switch that and you would have been fine. Like, you knew the other stuff, or it seemed like it at least. But you haven't even attempted it again. So when does a p-series converge? If p is greater than 1. Right? So my question now is, okay, how can I get 3 minus 4k to be greater than 1? Again, the question is asking for which values of k. So let me just solve this inequality. All right, so this would be 3 greater than 4k. So k just has to be less than 3/4. Wait a minute. What the heck? Where'd my 1 go? I lost the 1. So I guess actually it'd be easier to just subtract 3. Oops. So we'll say 1 minus 3, so that's -2. Divide both sides by -4. Since we're dividing by a negative, change the direction of the inequality. -2 divided by -4, positive 1/2. So k should be less than 1/2. It also says give a reason for your answer. So I sort of did that over here. So I could write that a little more formally, I suppose. So we'll say from 6 to infinity, I guess -2, 1 over n to the 3 minus 4k is a p-series which will converge if p is greater than 1. Okay, so that's a good explanation. Right, we manipulated our series so that it is a p-series, and we know that it converges if that exponent, n to the whatever, is something that's larger than 1. So in order for that to be larger than 1, then we solved and found that k must be less than 1/2. Okay, part E. If you're using the file that I sent you, I forgot a piece. So from the Smart Notebook file from previously, that I previously sent, this picture is not in it. Okay, I forgot that, so I went in and put it in to the file last night for part E. So just be aware of that. If you're looking at your Smart Notebook file right now, it doesn't have this part. My bad. My bad. Okay, so I have this graph. This is a graph of W prime. Right? Always important when I first look at a graph to see what am I actually looking at, which function. Am I looking at W, W prime? Am I looking at F? Okay, but in this case it is W prime. So for t between 5 and 18, the graph is given above. The areas, the regions bounded by the graph. Okay, so it's nice. It gives me the areas. That'll probably be useful. I'm assuming it's going to ask me to find some integrals. So find the absolute minimum on the closed interval 5 to 18. Justify your answer. All right. Since it is asking me not about a relative minimum or a relative maximum, it's asking me about absolute minimum, I'm automatically thinking extreme value theorem. That's exactly what the extreme value theorem does, is it finds absolute maxes or mins on a closed interval, which is specifically what we're being asked. So for extreme value theorem, so we got to do a couple things. We have to test the endpoints. That's where the absolute minimum could show up, right? So either 5 or 18. And test critical points. All right, so we have 5. Both the 6th and the 4th already passed. You're late, Hayden. There's always a bigger 5th. Yikes. Yikes. Okay. How do we find the critical points? So that will be where the derivative is equal to 0. So where is the derivative equal to 0? Well, we have options. Look, we have a graph of W prime. So A, B, and C. Now, I'm going to write A, B, and C here, but I'm going to make some changes. So I don't even know what these specific values are. I just know it happens at A, B, and C. Okay. Actually, B and C are not, so those are critical points because the derivative is 0, but they're not going to be a value or a valid option if I'm trying to determine the absolute minimum. Right? Because remember, minimums in general, right, whether it's a relative minimum or an absolute minimum, they always go from decreasing to increasing, right? Because the function is going down and then hits the minimum and then starts going back up. So what that means is the derivative should go from negative, because a negative first derivative means decreasing, to positive. A positive first derivative means increasing. So the only place that happens out of A, B, and C is here, at A. At B, the derivative is positive, so it's increasing. It hits B and then keeps increasing Okay, so it does not go from decreasing to increasing, so this can't be a minimum. And then same thing for c, but for decreasing. It's positive first derivative, so the function's increasing and then is decreasing. Well, that means c is going to be where there would be some kind of maximum, either a local max or an absolute max, whatever. But so I actually don't even need to test b and c, right? We have kind of logically eliminated that b and c are even options. So we need to test 5, a, and 18. 5 and 18 because those are the endpoints of the interval, so we always have to test those. And then a because that's the spot that we found where the derivative is 0, and it could be possible. It makes sense logically that a minimum could be there. All right. W of 5 we already know is 1. So that comes from this. We've used this so many times now that W of 5 is 1. Okay. For A and for 18, we're going to need to create an expression that represents W. Right? Because we do not have an equation for W. We know this initial value. We know W prime. We have equations for W prime. We have a graph for W prime. But we need to create an expression for W. So we've done that a couple times. And when we're trying to create an expression for a function that is the integral, we always want to use our initial value. Okay, so let's say W of t minus W of 1. From the fundamental theorem of calculus, that represents the integral of W prime. Actually, let me not use t. Again, we like to change the... it doesn't matter. Let's just say x, not dx. From 1 to t, right? The upper bound minus the lower bound, so 1 to t. All right, and I'm trying to create an expression for W of t, so W of 1 plus 1 to t W prime of x dx. So now for these values, so W of A and W of 18, I can use this expression to figure out what that should be, right? What those actual values are. Move them over. All right, first up, so W of A, so W of A equals W of 1. Or wait, sorry. I messed up. We don't know W of 1. We know W of 5. Right? I miswrote that. The Y value, this equals 1, but W of 5. My apologies. All right, so that would change that bounds too. So from 5 to t. So W of t minus 5. Okay, so W of t equals W of 5, which is 1, plus the integral from 5 to a. All right, well, integral from 5 to a represents area under the curve from 5 to a. So between here and here, what is the area? Well, that's 3. And since the area is below the x-axis, that's a negative. So 1 plus negative 3. So negative 2. Now for 18, so W of 18, again using this expression, is W of 5, which is 1, plus, so now the area under the curve from 5 to 18. So between, let me erase this stuff just to make it a little bit easier to look at. So starting at 5 all the way up to 18, what is the area under that curve? Well, let's add it up. We have a 3, but it's below the x-axis, so -3, +5, +1, and then 7, but below the x-axis, so -7. That'd be +2, 2 plus 1 is 3, 3 minus 7, -4. So 1 plus -4, which would equal -3. We're looking for the absolute minimum, so we just want to pick the smallest value, which is this. So now let me write out my final answer. W of 18 equals -3 is the absolute minimum on the specified interval. Right, on the closed interval 5 to 18, because that's what we specifically were asked about. Justify your answer, so by the extreme value theorem. Right, and we showed we did that up here, testing the endpoints, testing the critical points, looking where W prime equals 0. Okay, last one I think for today, F. Yeah. Part F. So again on part F, on your file, this is not here. Sorry. A particle moving along the x-axis has velocity v modeled by the function v is w prime. V equals w prime. Okay, so v is w prime. So up here, my graph is of w prime, which actually means my graph is also of v. Those are the same thing. For t greater than or equal to 5, v is measured meters per second. Great, 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 great. Find the integral from 5 to 18 of the absolute value of the velocity function. Also interpret the meaning. Okay, so first let me just find the integral itself. So 5 to 18. V of t dt. So if you want, or if you need to think about it, remember it says that v of t is the same thing as w prime. So if you wanted to change that back to w prime, you would be fine doing that if you wanted to. Okay, and so what does it mean when we take the integral of an absolute value? Okay, well what this represents is we don't want to think about positive and negative areas under the curve. We just want to consider what is the total area altogether, right? Forget about negative, positive, right? So that's why we have absolute value. Okay, so well let's just look from 5 to 18. So 5 to 18. And add up the areas without considering negative. So 3, instead of -3, it's just +3. +5, that's already positive. +1, already positive. And instead of thinking about this as -7, we're just going to think about it as +7. So adding that all up, I would get 16. I guess I'll write it out a little more specifically. So absolute value of -3 plus 5 plus 1 plus absolute value of -7. Okay, because that's what this tells us to do if we see absolute value, right, RJ bars inside of the integral. It means, hey, if you get a negative area, make that area positive. Okay, so we have to kind of split up and think about each piece of area individually. Okay, this piece of area is negative, take the absolute value of that. This piece of area is positive, all right, that part's fine. This piece of area is positive, that part's fine. This piece of area is negative, all right, let's do the absolute value of that one. All right, so it's kind of splitting up the integral into what stuff is above or below. RJ, you always get shout-outs, man. What would this class be without RJ? I don't even want to think about it. My God. All right, so besides just finding, interpret the meaning. Okay, so this is another formula that I kind of have to just think about knowing. Right? Integral of absolute value of velocity. So if the absolute value bars were not here, when I integrate velocity from wherever to wherever, then what that represents is the displacement. Right? So it would represent the distance between where the particle started and where it ended, right? Just displacement. However, when I take the absolute value, you might remember that that represents then total distance. So total different distance traveled by the particle from t equals 5 to t equals 18. So the integral of the velocity, just the regular integral, represents displacement, the change between where it started to where it ended. But total distance traveled is total distance traveled, right? It's like if you're running around a track, right? If you run around that track 4 times, your displacement is 0 because you start and stop at the finish line, right? But your total distance that you traveled was a mile. Right? So displacement is just the change between where you started to where you ended. And I think, so yeah, all right. Tomorrow, one of these is really long. Is it B, C, E, F, G, H? Yeah, this goes all the way to H for BC3. Tomorrow will be interesting. We might not even get that far. And some intense stuff tomorrow. A lot of series tomorrow. Converge and diverge. Every one of these questions, part A, converge or diverge. Converge or diverge. Show that it diverges. Or find, determine if it converges or diverges. 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 So everything tomorrow will be converges or diverges. Right, a lot of series work. Okay, and again, series, geometric, ratio test, P series / harmonic series, and alternating series. Those are the ones that you need to work on or focus on. Otherwise, keep doing the same stuff that I say every day. Practice these FRQs on your own, even if it's things you've already done. Use the AP playlist on their YouTube channel for BC. Do the timed practice. Go to the demo on the site. Practice uploading pictures. Again, if it were me, I would do it on my phone, just so I don't have to worry about transferring a photo from somewhere to somewhere else. But that's just me. I would deal with having to scroll, whatever. I'd be okay with that. When you're writing out your work, make sure that it's clear. Make sure you can take a good picture of it. You can use pencil. They recommend using pen. That way it's dark enough that it shows up well in the pictures. So you can use pencil, but make sure you're writing hard enough and that you can take a good picture that it clearly shows up. Not like, oh yeah, well you can see it, if you look close and squint and turn up the brightness, then yeah, you can see it. No, it should just be clearly readable. So whatever you need to do to make sure that's the case, do that. Any questions, AP test related or class related? Okay, let me know if you have any questions. Hayden, I'm sure, is going to go take that PFA that he didn't pass before. He's going to pass it perfect 10 out of 10. Yeah, let me know. And I'll see you guys tomorrow. We'll do a lot of converging or diverging series. It'll be great. Don't jinx me, man. All right, Hayden's going to get 0. How about that? Is that better? Does that not jinx you? Too late. All right, well, fine.